If you take a look at this, this is the sample questions the government gave us like 8 years ago. There's lots of them. But just to let you know, first of all, how the multiple choice works, multiple choice questions are divided into what they call knowledge questions. A knowledge question is one that technically is supposed to require no calculation, but really it means it's one that you can do in your head with maybe one step of calculation. For example, what's the common ratio of this? Okay. I'm not going to go over the knowledge questions with you guys, because I'm going to assume if you're here, you can handle those. Then they have what are called understanding questions. Those are questions that involve a couple of lines of calculations. Probably not going to go over too many of those. What I want to do today is go over what are called the higher mental processes. These are what I've called the curveballs, and the written. Okay, so very quickly, here we go. So hopefully you're following along, or you can see up here. This is an example of a classic series and sequence higher process question. X minus 1, x plus 6, and 3x plus 4 are the first three terms of a geometric sequence. Determine possible values of the first term. How many answers? Because, of course, by now you always glance at the answers before you move on. How many answers? We're going to get a quadratic. Must. Right? Oh, how do I do one like this? They love to throw this one on here. We realize that x plus 6 over x plus 1, that's one value of r. We realize that 3x plus 4 over x plus 6, that's a second value of r. Now, how can I solve this equation here? X minus 1, x plus 1, thank you. Like I said, it's the dumb mistakes are the toughest to get out of our system. There's one. How can I solve this question? Please, let's be at the point where we glance at this and we know what are we going to do right away. Okay, cross multiply, you'll get a quadratic. You'll solve for x. You'll get two answers for x. Then you'll have to plug the x values in to right there. So whatever x value you get minus 1 is your two answers. I'm not going to go further than that. Here's an understanding. Here's some kind of the, this is a written word problem, except you're not going to see a written question on series and sequences because they made it worth less of the exam. Okay? Dylan, you want to sit next to somebody so you can follow along on this document if possible. Here's an example of an H question as well. This one is a written question, and this one I've never seen before, so I'm going to cover it in about 30 seconds, and I'm going to say don't let it freak you out. It says the first and second terms have a sum of 15, while the second and third terms of a geometric sequence have a sum of 60. Find the three terms. And here's what they've said. The first term is A. The second term is A times a single R, because you multiply by R each time. Is that okay? That adds to 15. The second term is AR. The third term would be this times R, which would be an extra R or an R squared. That adds to 60. Then they've gotten very clever and they've factored out a GCF. Okay, fair enough. And then what they're going to say is they're going to go, look, this divided by that has to be this divided by that. 60 divided by 15 has to be AR times 1 plus R divided by A times 1 plus R. Sally, can I cancel? Are they factored? Yes. And you get AR over A equals 60 over 15. Now what? Yeah, cross multiply. Oh, the A's cancel as a matter of fact. In fact, you get R equals 4. Now you can work your way back here now that you know what R is, and you can figure out what the heck A has to be and figure out the terms. Series and sequences is almost certainly going to be multiple choice, though. So here's another, well, here's a knowledge question, how many terms? Knowledge question, how many terms? Understanding, how many terms? Oh, here's a higher mental process. If the sum of n terms is given by this expression here, find term 4. Not the sum of the first 4 terms, but term 4. You may remember one of the last lessons that I did this year, we said this. The nth term is equal to the sum of the first n terms minus the sum of the first n minus 1 terms. For example, I'll just make up a sequence here. I'll go 2, 6, multiplying by 3, Mr. Dueck, 18, 18 times 3 is 54. If I add these, here's what we're saying. If you want to find the fourth term, It's the sum of the first 4 terms, take away the sum of the first 3 terms. Isn't what's left the 4th term? Okay. Here's a cross-topic higher mental process question. So evaluate this here. Here's sigma notation. I don't know if you can see, but k is 3. So the first thing that I would do is I would write, well, log base 3 of 3 squared plus, and then k is going to be log base 4 of 4 squared. And then it's going to be log base 5 of 5 squared. I'm just plugging in k values as I go along from 3 to 5. Matt, what can I do with this exponent? In fact, then I'll have 2 times log base 3 of 3, which is just plain old 2 plus, and when I move this to the front, I'll have 2 times log base 4 of 4, which is just plain old. Oh, actually, this falls apart. You know what the answer is? 6. Pass that one. Understanding. Talking about for an infinite series, you need to know that R has to be a fraction if it's going to converge. So here is a higher mental process. Evaluate this question. Here's an infinite series where n starts from 1 to infinity. To do this one, I would start out with that. Then I would go like that. Then I would go like that. And then I usually from 3 terms can figure out the pattern. So I would stop here. I would say, oh, I think R is 1/3. Is 1/3 a fraction between -1 and +1? Then it will converge. The infinite sum is equal to this. The first term is 1/3. R is also 1/3. You'll get 1/3. I think you'll get 1/3 over 2/3. How do I divide by a fraction? Flip it and multiply. There's the 1/2 comes from. There's where the 1/2 comes from. Now the other one that is cropped up, and I've thrown this at you on a couple of exams, is this one here. So when they have ... that's telling you it's an infinite series, and it's saying for this to have a finite sum, the fancy word for that is for this to converge, R has to be between -1 and +1. What's R in this case? What am I multiplying each term by? Troy? X plus 1. We're saying -1 has to be smaller than x plus 1, which is smaller than 1. How can I figure out what x is? Now you can kind of scratch your head, look at the answers, and kind of do it intuitively, but this is a 3-sided inequality. To get the x by itself, you can actually go -1 from all 3 sides, and you'll get -2 less than x less than 0, which is the correct answer. Bouncy ball question, I've already talked about that. I hate it. It's written anyways, so I'm going to pass on that. Find the sum of an infinite series, and now we move on to logarithms. So, what do you think this symbol here means? No calculator. So on your exam, they're going to give you a non-calculator exponential. What it's going to be is, it's going to have exponents that are powers of each other. What do 81 and 1 over 27 have in common? 3. This is actually 3 to the 4th to the x minus 1 equals, well, 27 is 3 to the 3rd. What's 1 over 27? 3 to the -1, elevator. So 3 to the -3, sorry, I said 3 to the -1 to the x minus 4. What can I do with these exponents here? What's my power to a power rule? So I get 3 to the 4x minus 4 equals 3 to the -3x plus 12. Are my bases the same? Do I have one base equals one base? Remember me doing that phrase way at the beginning of the year? Then I can equate the exponents. The equation I'm going to solve is that one there. Negative. Plus 3x to both sides, minus 4. No idea what the answer is. I don't care. Higher mental processes. So the same kind of a question. Here's the kind of curveball that they can throw at you. What do all of these have in common as an exponent? 3. So I'm going to write this as 3 squared to the x plus 2. Now these are already powers of 3, but there's 2 of them. Oh, are my bases the same? When I'm multiplying, what can I do with the exponents? Yeah, as it turns out, this is 3 to the 4x minus 3 plus 5. You can add the exponents. Gather like terms. What is negative 3 plus 5? Yeah, really, this is going to be to the 4x plus 2. Multiply that, and you'll go 2x plus 4 equals 4x plus 2 and solve that. So there's an example of a curveball on this topic. No calculator, basic knowledge, solve for x. Yeah, basic knowledge, solve for x. Here, rewrite it as a logarithm. That gets the x by itself, right? Whatever the x is an exponent. Here's an example of a higher mental process non-calculator question. Solve for x, a times b to the x equals c. How would I get the x by itself? First thing I would do is I like to get the exponent by itself. So the first thing I would do is do this. Where's the x sitting? So log both sides. I'm also glancing at my answers. Hopefully when you glanced at the answers, you would also say at one point, oh, I've got these, oh yeah, they split this apart. What's dividing inside a log the same as outside a log? Subtracting. I can write this as x log b equals the log of c minus the log of a. And how would I get the x by itself? Divide. There it is. Okay. Here's a written question, higher mental process. So this is a tough question. An easier question would be if they don't have a coefficient there. If they do have a coefficient there, now normally I like to get the exponent by itself. The problem is I got exponents on both sides. So I guess I could divide by 3, but I'm going to have exponents on both sides that aren't by themselves anyways. I would take the log of both sides right here. I would remember that this x can move to the front, but this x plus 1 cannot move to the front because it is not on the 3. Instead, I would say to myself, what's happening between the 3 and the bracket mathematically, Matt? Oh, how do I break up logs when we're multiplying inside? Adding, and then move the x to plus 1 to the front with brackets! By the way, those who did the second mock, the trig identity, one of the reasons many of you had trouble with the right-hand side is because you didn't honk and write brackets in there. It drove me crazy! There was a minus minus that became a plus, and then you... Anyways, brackets! Hey, rule of thumb, on a test, if you're ever substituting, it never hurts to put what you're substituting in brackets, ever. Sometimes they're unnecessary, but if you're not sure, put them in always. Then we go like this. How many x's do we have? 2. How many would we prefer to have? Let's get them both to the same side. It'd be wonderful if there was some kind of a grade 9 mathematical operation, GCF, and then you have to be able to type this into your calculator. This is a question that has about a 60% chance of being on your exam, those of you that are writing the provincial. Who's writing the provincial here? Okay. Pardon me? If you're doing a rewrite? Makes sense. Okay. So, they like this question. We have log questions. Now, this is non-calc. What's adding 2 logs the same as? So you would write this as the log of 3 minus x times 3 plus x equals the log of 5. Do I have 1 log equals 1 log? Yeah, now the logs cancel when I have 1 log equals 1 log. Here's what you can't do. I see a bunch of kids multiplying this out for some reason as though it's FOIL. It's not. Or I see a bunch of kids canceling out the logs. You cannot cancel out more than 1 log equals 1 log. Logs are not like variables. They're not GCFs. They're mathematical operations. You can only say if you have the log of something equals the log of something, the two somethings are the same. So the equation you would get would be 3 minus x 3 plus x equals 5. Ari, now what would I do? Multiply it out. I'd get a quadratic, make it equal to 0. Oh, what can't I take the log of? Negative, so you'd have to see if you did get an extraneous root, right? Another example here. Here's an example of a higher mental process. They'll give you a log, log, log. If you're doing a log, normally I try and first of all see, is there something that will simplify first? If this was a number here and it simplified, I would try and do that. There is not. So I start on the outside, and I'm going to write this as an exponent. 2 to the negative 1 equals what's inside the log. By the way, what is 2 to the negative 1 as a fraction? Elevator? 1/2, so I'm going to do that. I still have the x inside of a log. If the x is ever inside of a log, and you can't cancel the logs, you're going to want to write it as an exponent. 4 to the power of 1/2. 4 to the power of 1/2 equals what's inside the log. By the way, 1/2 as an exponent, what mathematical operation is that really? Square root. This is really the square root of 4. Hey, what is the square root of 4? Oh, you're kidding me. 2? Really? Now what? Is my x still inside a log? Then write it as an exponent. 5 to the power of 2 equals x. There's your 25. Don't you dare pick 10. Don't do all of the math 12 and then get sloppy on the math 8. Here's the next kind of typical log written question. They're either going to give you an exponential equation like this one right here, okay? Or they might give you a logarithmic equation like this one right here. A logarithmic equation is an equation that has logs in it and x's. Okay. First thing I would do is I would move this up so that I have the log base 4 of x squared equals Mr. Dueck, nice try, minus the log base 4 of x plus 3 equals 1. Dina, what's subtracting 2 logs the same as? Dividing. So this is the same as the log base 4 of x squared all over x plus 3 equals 1. Do I have 1 log equals 1 log, Dylan? So can I cancel? No. Where is my x sitting? Inside a log. What do I do then? Write things as an exponent. This to the power of this equals what's inside the log. By the way, what is 4 to the 1, Leslie? So I'm going to get rid of that. Except I thought that would erase. Let's try that again. How would I solve this? I don't know. Yeah, yes, you do. How would I solve that? You're going to cross multiply. You'll get a lovely quadratic right there. It factors, and then you're going to find, always check what can't I take the log of. Can't take the log of a negative. Putting a negative 2 right there. This one here is extraneous. Okay. So the log question is usually the second written question. Usually the first written question is transformations, usually. So you can expect your second written question to be a logarithmic question, either an exponential equation like the one I did about 2 minutes ago, or one of these, or a word problem, half-life exponential growth, which we'll do in just a second. Simplify. Write as a single log. They like to do those as well. What if they give you a number that's not a log and they say write it as a log? What's my base here? 2. Yes? 3 is actually the log base 2 of 8. There, I've written it as a log. I can write any number as a logarithm by going the base to the power of the number that I'm trying to write as a log. 2 to the 3rd is 8. That means log base 2 of 8 is the same as a 3. You can replace any number with a log. Is that okay, Sally? Did I lose you there? What's the log base 5 of 25? In your head, you have to be able to do this. Help us out. What's the log base 5 of 25? 2. What's the log? Okay. What's the log base 2 of 8? It's a 3. You can, any number can be written as a logarithm if you want to. When would you want to? If they say write as a single logarithm, and that's not a logarithm, you better write it as a logarithm before you can start using your log rules. Okay. Don't forget your change of base. So if log base 4 of x equals a, determine the log base 16 of x in terms of a. Here's an if-then question. What's my base of the then? What did they give me here? What's the base? It's What's my base here? This base change. I'm going to rewrite this as base 4. What's my base change law? Base 4 of x over log base 4 of 16. Why does that help? I don't know yet, but, oh, Sally, what is the log base 4 of 16? 2. And you know what the log base 4 of x apparently is? A over 2. There's your if-then questions. And you could recognize a little bit of what they want you to do. Here's what I said to you folks. If they have a different base change law. If there's one log, break it up. If there's more than one log, combine it. Okay? Here's a tougher one. Here's an H question. Here's a curveball. If the log base 2 equals A and the log base, if the log of 2, when they don't write a base, by the way, what is the base? It's called the common base, base 10. So the log base 10 of 2 is A, log base 10 of 3 is B. Determine an expression for that right there. Huh? What number is this? 2. What number is this? 3. I would write this as powers of 2 and 3. I know that this is 8 times 3 times 100. 24 times 100. Why did I pick 8? Because that's a 2. Why did I pick 3? Because that's a 3. I can write this as the log of 2 cubed times 3 times 100. How many logs is this? 1. Break it up. This is the log of 2 cubed plus the log of 3 plus the log of 100. And I'm really twigging on this right now. Sally, what's the log of 100? 2? Are there 2's in my answers? And I glanced at those ahead of time, spotted those, and said, I bet you know where they're going. This is actually, because it's base 10, 10 to the 2 equals 100. That's a 2. What's the log base 3, apparently? Sorry, log of 3. It's either this one or this one. Oh, the 3 can move to the front, and then I have just a plain old log base. Oh, I have just a plain old log of 2, which is A. There's an example of an H question. Multiple choice, non-calculator. Here's another one. This one is throwing a few of you off. Here is your hint. What's my base? Hey, what's my base? This is asking, do you remember this rule? You use different letters, Mr. Dueck. Q to the log base Q of x just equals x. When your base and your base were the same, this was the answer on ground level. Now, I need to write this as a single log. This is A. Adding is the same as multiplying to the power of log base A of 16. Now I've got my bases matching. The answer is just plain old 16. Okay? Here's another if-then H question. So determine the value of log base n of ab squared if log... So here's my then. Here's my ifs. How many logs did they give me here? 1. Are my bases the same? Well, then I'll break it up. First thing I would do. So I'm going to break this up into log base n of a plus log base n of b squared. Oh, this is good. You know what log base n of a is, Dina? That's just 5 plus something. Oh, I can move the 2 to the front, and I have log base n of b. Oh, but you know what log base n of b is, Dina? Oh, 11. Number 16. How many of you already spotted that we might get a quadratic? Did you not glance at the answers and see the plus or minuses right away? Oh, plus or minus, I bet you, or we're going to square root plus or minus. You can get a lot of information on the multiple choice by glancing at the answers. This is an H question for logs. By the way, all of these will not be on your final exam on the non-calc logarithmic section. Almost guarantee one of these will be. Maybe 2. Probably not. I probably just uno. So Well, what's that? What's your base? What's your base? Are your base and your base the same? You know what this simplifies to? X on ground level. What's this? Well, there's an 8 there. What's right here? A 2. I'm going to write this as the log base A of 2 cubed. Except, no, I'm not. I'm going to move the 3 right there. Except, no, I'm not. You know what the log base A of 2 is apparently the same as? Okay. Sometimes that works and sometimes it doesn't. This is 3xx. Oh, what's an easier way to write xx? X squared. And if I divide by 3, I'll have that. Square root both sides, plus or minus. Now, they want, oh, wait a minute. Can x be negative? Not when it's inside a logarithm, so sorry. Just plus 2. They want what a is, so I got to go walking back over to here now, because they didn't say solve for x, they said solve for a, and sneaky of them to have 2 as an answer, because you might have circled that, so proud of yourself. That's not what I wanted you to find. So now I have this. Adam, a squared is equal to 2. Write it as an exponent. Guys, can't freeze it. If it's somewhere you don't like it and you don't know what to, write it as an exponent. Or if it's as an exponent, write it as a log. You can always move the stuff around. How would I get the squared by itself? Plus or minus. Oh, but you can't have a negative base either, so you would have to get rid of this. Hody, hody. No, no, no. Just hang on a second. Sorry for the interruption. Remember a couple of other things. If you come to a nasty, glance at the next question. If it's a different topic, you know this is the nasty on that topic. They almost always put the real nasties last question. Now, I guess that means if you come to a nasty and you see 3 log questions afterwards, then it's probably not meant to be a nasty. That means relax. Probably it's up here somewhere. Don't panic. Let's keep going. I think let's keep going. There we go. Oh yeah, so here's our knowledge, right? Write that as an exponent. I'm assuming you can all do that. Here's one that seems tough, but it's meant to be really easy. If a comma b is on y equals 3 to the x, which point must be on the graph of that there? Now that looks really tough, except what's my base? What's my base? Exponents and logs are inverses of each other. How do I find an inverse? That's the point that's on there, folks. Logs and exponents are inverses of each other. Okay? So if you know one, you know the other. So here's a classic, find the inverse of this. First of all, if you're ever finding an inverse, how do I find an inverse? Okay, to find an inverse equation, this is the one time I think function notation is terrible. I always replace this with a y, first thing before I do anything else. Then I switch the x and y around. X equals 3y to the y minus 1 plus 2. Minus 2, that's what I said. Can't you read my writing at this time of the year? Good gosh. You guys don't realize how disgusting this is, but every time I have a Timbit, this thing just gets plastered, so I'm not going to have any more Timbits for a while. Ugh. If you ever saw this screen, it's pretty disgusting. Sorry. I might be done. Quickly glance. No. You know what? They want me to get the y by itself. Where's the y sitting? Exponent. So what am I going to do? Oh, listen up. I'm not going to take the log of both sides yet. What did I say I always wanted to do first before I took the log of both sides? If I could get the exponent by itself, I would do this first. By the way, see that? Yes? No, no. I hope you would do that right away. It's not x minus 1. It's x plus 2. Even if you can get that far, now it's a true or false question because you're only picking from 2. Start crossing out wrong answers, people. Log both sides. and I move the exponent to the front right away, in brackets. Divide by the log of 3. Now, I don't see it divided by the log of 3. Oh, I see log of base 3. They're writing this as a base change law, the sly dogs. So instead of writing this as base 10, what they're saying is, look, that's the same expression. Because that's how you would evaluate log base 3, is you would do as base 10 over log base 10 of 3. And then how would I get the y by itself? Plus 1. Okay. I think this is somewhat of an H question. They're higher order. They're calling it, nope. So, okay. Compound interest, getting the equation. Remember, remember this. Where you have your final amount, initial amount. You know what? I would have glanced at this, I would have glanced at this, and I would have said, I don't care about those, apparently, because they're the same in every question. 7.2% per annum. Now, at first, you might think that that means 1 plus 0.072, but that was not quite right. What you had to do was look at the compound period. We're compounded monthly. What does monthly mean? How many times a year? 12. So if it's 7.2% for a whole year, how much for a month? What you had to do to get the actual percentage was this. It was 1 plus 0.072. There's 7.2% as a decimal. Divide that by 12. So the number of years divided by, and the period was 1/12 of a year. By the way, dividing by 1/12, what's that the same as multiplying by? How do you divide by a fraction? Flip it and multiply. Same as multiplying by 12 over 1, which is really the same as multiplying by 12. It's not this one. Okay. Most common answer kids pick is this one or that one. If they give you base E, they will give you the equation. They want the final population 20 years from now. So that 20 years, I think that's a t value. I think all they want you to do is this. 25 times e to the 0.022 times 20. Where the heck is your E button on your calculator? It is there somewhere. I think it's second function ln. You also, it's right below your pi button, but there's two ways to do base E. The second function ln has the exponent for you already. 25 times second function ln e to the power of bracket 0.022 times 20. 38.8. There. Okay. The only other thing they can do is they can ask you to solve for something up here, which is just like logs, except don't use your log button. Use which button? ln. Word problem. Absolutely a good chance that there is a word problem on the written. So this one here says the population of a nest of ants can multiply threefold, triple, that's your growth rate, in 8 weeks. That's your period. And a way to find the period is often the word every will appear in front of it. Could you say this as can triple every 3 weeks? Yes, that's your period. It's going to be A equals A0C to the T over P. Final amount, 300,000. Initial amount, 12,000. Triple, they want me to find T, period is 8. So here's your equation. Where's the T sitting as an exponent? Log, no, get the exponent by itself first, so divide by 12,000. Now take the log of both sides. Move this to the front. I don't like the way they've typed that fraction. I would write it as the log of 25 equals T over 8 log 3, because that way hopefully you can clue in, hey, it's cross multiply. Times by 8, divide by log 3, and away you go. Or they love to ask you a half-life question or ask you to find the period. So it's the same equation. But if they ask for the half-life, that's the growth period. Or they'll say, what is the growth period, or the doubling period, or the tripling period? That's also your clue. They want you to find the period. Final amount, well, it decays by 20%. So if you lose 20%, how much is left? Final amount is 80%. Initial amount is 100%, which is just 1 as a decimal. Ooh, I like that. When it's a half-life question, what's your growth rate? Always a half to the 30 over p. That's the equation you're going to solve. Nice thing about this one, Leslie, is you don't need to divide by 1. It's convenient. Take the log of both sides. Again, I hate the way they've written this fraction when they moved it to the front. I would write it as this. Log of 0.8 equals 30 over, and I use the letter p, log 0.5, because again, now I would hope you would clue and you can cross multiply. Okay, that's going to be the written of logarithms: exponential, logarithmic, or word problem. Usually word problem, about 50% of the time. About 30% of the time exponential, about 20% of the time log equation. Gotta go faster. Another word problem. I'm going to pass on that. Graphing. It says graph. You know what? They won't ask that anymore. This is before they had a non-calc section. They're not going to do that as a written question. Domain of a log function. What's inside the log has to be positive. Get the x by itself. How? Minus 3 and divide by? X has to be bigger than negative 3 over 2. Okay? Don't forget Richter scale. Richter scale was 10 to the bigger minus smaller equals how many times stronger? pH, they'll give you a lovely chart. Same idea, if they ask it at all. Non-calc question. If A is a fraction, which of these is the best graph of that? Now, if A is a fraction, remember we did exponential graphs. Every exponential graph looks like what? I always had somebody in each class do this or this and hit the kid next to them. Okay, remember that stupid thing? Okay, there are two types of exponential graphs. Looks like this. Y equals 1/5 to the x. Looks like this. There are growth and decay, and it all depends on whether your base is a fraction or not. So what I would do to answer this question is I would sketch this really quickly, and then this is also a fraction. It's the inverse of this thing. So I would say, for example, let's see, this goes through 0, 1. Mine's going to go through 1, 0. No. No. There's the first step. Then I would make up a point. This looks like it's about 7, 0.5. So mine's going to go through 0.5, 7. Got to be that one. You can very quickly do a rough inverse. That's not on the exam. Trig. So radians to degrees, degrees to radians. They'll either go exact value questions, non-calc, or they'll go decimals calculator. Okay. Arc length. Remember the arc length equation looks like the word arc. Just do that. Oh, but you have to be in radians. So you'd have to convert 135 degrees to radians. 135 degrees is 3 45s, and 45 is one of the ones we memorize. It's pi by 4. Here's x. Here's y. Could you figure out r? Yes. Now they want the arc length. So I would say, okay, a equals r theta. This is a higher mental process. This is tougher. I could figure out r, and then I'd have to figure out theta by looking at the fact that I know x, y, and r. I know sine and cosine. I have a triangle with a 1 and a root 3 in it. I can figure out what the heck angle this is. I think it's probably going to be 7 pi by 6 or 4 pi by 3 is my reference angles, and I could do the math. Sorry, but we're rushing here. Determine the exact values. So all your exact values for your special triangles. Okay. Tangent, secant. Be prepared for a negative. Oh, there you go. Negative means you're going in that direction around the circle. Okay. Solving first and second degree trig equations. So, solving a quadratic trig equation. Now, this will almost certainly be on your written section as well. It's often on the multiple choice, but it will almost certainly be on your written. You have to be able to factor one of these bad boys. This factors into 2 cos x minus 1 plus 1. How can I tell that I factored right? FOIL it out if you're not sure. My roots are cos x equals negative a half, cos x equals positive 1. For cos being negative, cosine is negative here and here, which means I'm crossing out. This answer can't possibly be right because 11 pi by 6 is down here. Oh, and this answer, 2 pi, oh, hang on, 2 pi by 3 is in my proper quadrant. Anyways, I got rid of one wrong answer. Do I have a triangle with a 1 and a 2 in it? Yes, I do. So, Elizabeth, I would draw my triangle like this, with a pi by 6 right there and a pi by 3 right there. Always, 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 always. Which of these two angles, the bottom one or the top one, has a cosine of 1 over 2? Top. Adjacent over hypotenuse. How big is that angle? Pi by, did you say pi by 3? That's gone. It's not pi by 6. This is pi by 3. This is pi by 3. And this is 3 pi by 3. So it's 2 pi by 3 and 4 pi by 3. No. Yes. Now, I didn't get the 0. I would quit here, by the way. But also, where is cosine 1 high? When you sketch the cosine graph, it's 1 high right at 0. Okay. Again, solving first degree equations. How do I solve a reciprocal trig function? I don't solve cosecant equals 2. I solve, what does cosecant go with? I solve sine x equals 1/2. Hey, that works. Sine is positive there and there. This one's wrong for sure because 11 pi by 6 is down there. This one's wrong for sure because 4 pi by 3 is down there. In fact, you know what? All I need to do is find out whether the reference angle is pi by 6 or pi by 3, and I'm going to quit. Right? Elizabeth, I draw my triangle like this. Elizabeth, my child, which angle has a sine of 1/2? The bottom one or the top one? How big is that there angle right there? Darn right. I'm quitting. I'm not going to find all. Right, on the multiple choice trig equations, you rarely have to solve the whole thing. How am I going to solve this one? Tell me right now. Okay, graph left side, graph right side, find where they cross, change the domain. Don't waste time on it. You're laughing. I had a kid last year spend 20 minutes on this on the exam before they clued in. That's wasting 20 minutes. Now, the nice thing is you got 3 hours, so time should not be an issue. How many solutions where a is an integer? Well, here's my normal sine graph, and here is about 1/3 high. How many solutions are there normally? 2. What if I put a 2 there? If I had this, that's a horizontal compression by 1/2. That would give me this. How many answers now? 4. What if I put a 3 there? 6. Oh, you know what? 2a is the correct answer. There's always 2 times the number times b. I don't like the fact that they used a. I think that's confusing. We called it b. Why not use b? But whatever. Okay. Here's a period change. So this is considered an H question. Higher mental process question. Okay, how do I do a period change? I don't. I make a big note. Period is pi. It's 2 pi over 2, or just plain old pi. And I solve this. Here and here. Which triangle is a 1 over root 2? The 1 root 2 triangle. 1 root 2 triangle. And I would say my reference angle is pi by 4. I would say my first a value is pi by 4. My second a value is 3 pi by 4, because that's 4 pi by 4 right there. But they didn't want me to get a. They wanted me to get, I didn't write this. I should have written a equals 2x. They want me to find x. Matt, how do I get the x by itself? Oh, so instead of a 4, there's my first x value. And instead of a 4, nice try, Mr. Dueck. Instead of a 4, there's my first x value. And then they want more angles between 0 and 2 pi. Oh, and let's call them x's now, Mr. Dueck. Is there a third one? Well, take this pi by 8 and add the period. Is that still less than 2 pi? Yep. Then there's also another one. How did I get 10, Mr. Dueck? Because I can't add, apparently. Is that still less than 2 pi? Yep. You know what? I'd stop here. I found one more. This has to be the... Okay, it ain't that. It ain't that. There. I'm done. But there's also, if you add 8 pi to this, you get 11 pi. Okay? This doesn't show up on the written very often. It occasionally shows up on the multiple choice. So here's an example of a higher order. What don't you like about this? 2 different trig functions. Cos of 2x. Is there a cosine 2x equation that has only signs in it on your formula sheet? Speaking of formula sheet, you don't bring yours with you. It's in the exam. It used to be on the last page, tear out. I think now it's in the middle, tear out. But you will get a formula sheet with your exam. And it's perforated. You can pull it out. Okay. Yeah, this is sine x equals 1 minus 2 sine squared x. Oh, I like that better. What kind of an equation is this? Quadratic. How do I solve this? Make it equal to? Now, you could minus sine x, but I hate my quadratic to be negative. I would plus the 2 sine squared over, drop the sine x down, subtract 1. And then once you have that, it factors into 2 sine x minus 1, sine x plus 1, sine x equals a half, sine x equals negative 1. Cast rule, special angle, 1 over 2, 1, 2 root 3 triangle. Sine x equals negative 1. Alarm bell, Dylan, you would have to go to get that one. Sketch, oh, it's negative 1 right there at 3 pi by 2. Whew. Solve algebraically. Here's a domain change. How do you do a domain change? You don't. You don't. Instead, you solve it as is. So tan x equals 0. That's where x equals 0. Here, if I got cos x equals root 3 over 2, I would go CAST. Cos x is positive here and here. I'm drawing this really fast. My reference angle is pi by 6. So I have that as pi by 6. I have that as pi by 6. I have x2 equals pi by 6. x3 equals 11 pi by 6. Let's make that an 11 and not a 7, Mr. Dueck. Now this one here is not in my domain. No problem. Just subtract the period from it. Except I would not subtract 2 pi. I would subtract 12 pi by 6, which is 2 pi. It's the same angle, but now I am in my domain. I am between negative pi over 2 and positive pi over 2. So that's where that negative pi by 6 came from. There's the pi by 6, and 0 would come from the fact that tangent is 0 at 0, because that's what it is. Okay. Here's a higher mental process written, so here's a period change as well. And, oh, 8, where we have the between 0 and 2 pi. So when you solve, you find that one of your angles is pi, one of yours is 2 pi, which which is technically not in the domain because there's not an or equal to right there. X equals pi. And then over the real numbers, add the period. What's the period? Period is 2 pi over b. How do I divide by a fraction? Flip it and multiply. I'll finish trig and then we'll stand up and do a 30-second mental break. So general solution, adding the period. Quadratic trig equation. Over real numbers, general solution. So once you solve it, make it equal to 0, factor it, then add multiples of the period. What's the ugly cousin? Tangent, period pi. Here's one that showed up recently. They tell you that the sine of 3x, the answer is 0.26 and 0.79. Find the general solution. All they're saying is, do you know how to add the period? What's the period of this graph here? Not 2 pi. What's the period? 2 pi over 3. So the one solution plus 2 pi n over 3. Another solution plus 2 pi n over 3. Here's the big one again. Another quadratic trig equation. Oh, and it says give exact value solutions where possible, otherwise to 2 decimal places. When you factor this one, Jacob, you want to give Dylan an elbow? He's having trouble. It's the third time. You sure? Okay. You get sine x equals 2/3 and sine x equals -1/2. Do I have a triangle with a 2 and a 3 in it? No. So how do I find this? Find the reference angle, which is inverse sine of 2/3. Use the cast rule. We're positive, so we're here. First angle is whatever this is a 0.73. I'm betting. Let's find out, Mr. Dueck. So my reference angle is 0.73. That's the first angle. Second angle is going to be pi minus 0.73. See it? Okay, you get a decimal. That's where those came from. Oh, and if they want the general solution, add the period. Here I have a triangle with a 1 and a 2, so I can use my cast rule, special triangles, and all that good stuff. This is an H question. It's a written question. This probably would not make it onto the written, but anyways, the difficulty here is you have sine and cosine. In fact, you have sine 2x, although sine 2x is 2 sine x cos x. And now you have a lovely GCF of 2 cos x and sine minus cos. Here you get a root of 0. Where is cosine 0? Cosine is 0 here and here. That's pi by 2 and 3 pi by 2. Here you get sine x equals cos x if you plus the cos over. If you divide by cos, you get sine x over cos x equals 1. You know what sine over cosine is? You get tan x equals 1. I do have in fact, tan x equals 1 over 1. I do have a triangle with a 1 and a 1 in it for tangent. I don't have a triangle with a 1 in it for sine or cosine, though. Restrictions. Pause. All right. I've had a request for the quadrant numbers. I can certainly do that. Adam, as a nerd, here's what I will tell you. Believe it or not, counterclockwise is the natural direction of nature and physics. And really, had we been in charge, clocks would run that way. They should. Almost any physics process, counterclockwise is the natural direction that we prefer. So there's your quadrants in Roman numerals. You don't have to label them in Roman numerals, but they probably will be labeled in Roman numerals if they give them to you. Okay? All right, into the wonderful world of identities. The first thing is restrictions. Now, listen closely. For restrictions, what can't I divide by? 0. I don't care if a 0 is on the top. So I can't remember who I was yelling at the other day, but somebody was telling me, well, isn't 0 over 0, 0? Well, first of all, you can't divide by 0. And then they were saying, yeah, but you have a 0 on the top. You can't have a 0 on the top. Yes, you can. 0 over 4 is 0. Works just fine. Did I hit start? I did, didn't I? I'm having a mental blank here. Hey, I did. So, what you're really asking then when they ask for restrictions is, what fractions might have a 0 on the bottom? Now, here's a fraction with the denominator. This whole thing can't work out to 0. What that really means is that cosine can't be 1/2. Because if it is a half, you'll have 2 times a half, which is 1 minus 1. In fact, I'm using the old change the sign and divide by 2. I'm using the same trick that we used last year to find roots from brackets. But there's another fraction hidden in here, tangent. Tangent is actually sine over cosine. So what would make this fraction have a denominator of 0? Cosine can't be 1/2. Cosine also can't be 0. Do I care about sine? No, no. This one. Okay. Identities. When in doubt, rewrite everything in terms of sine and cos. So this is going to be sine squared theta over cos squared theta times 1 over sine theta plus 1 over sine theta. Oh, can I cancel? It is factored, so one of my sines cancels. Yay! Now what? Well, I'm glancing at my answers, and I notice there's only one of each term. Here I have 2 terms. I think I'll write this as a common denominator fraction. My common denominator fraction would be, let's move this over. My common denominator fraction would be cos squared theta sine theta. Please tell me I haven't done something silly yet, have I? No, that works so far. What would I multiply a cos squared by to turn it into a cos squared sine? Multiply top and bottom by sine. Oh, I get it. What would I multiply a sine by to get a cos squared sine? And I just got my nerdy adrenaline rush because I went, you know what sine squared plus cos squared is? This is 1 over cos squared theta sine theta. Rats, I don't see that anywhere. Oh, wait a minute. What is 1 over cos squared the same as? Secant squared. And what is 1 over sine the same as? Cosecant. This is secant squared cosecant. There's a classic multiple choice identity non-calc type of question. You're going to see most of the multiple choice identities on the non-calc, because if they put them on the calc, you can graph left side, graph right side, or graph your question, graph your answers, and just see which ones are the same graphs. Okay? Identities. I'll do a few at the very end if you want me to, but I'm going to make the assumption that you've seen enough right now that you at least understand the basic concept. I'm not trying to refresh your memory on those ones. It's, yeah, those are identities. I recognize them. So identities. Identities. Sum and difference identity. They love to throw this question on the non-calc section. Something like that. Or it'll be heck, they use cosine, Mr. Dueck. It'll be the sine of x minus 3 pi by 2. It'll be a variable, and one of your other angles is going to be either here, 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 one of the 4 corners of your circle. In this case, you need to recognize that this is a sum and difference identity. This is alpha plus beta, which is cos cos minus sine sine. Sine of pi. 0. So this whole thing cancels because 0 times anything is just 0. Cosine of pi. Right there. Oh, negative 1. Negative 1. Cosine of 2a. There it is. Now they could have, because cos of 2a, cos of 2x is also a double angle identity, they could have, to make this go from an understanding to a higher order, taken it one step further and required you to do a double angle identity. Or going backwards, cos plus sine you need to recognize that cos plus sine is actually cosine of alpha minus beta, where that's alpha and that's beta. Simplifying identities. Here's a more challenging identity. Remembering x, y, and r, so the point P, comma, Q, which expression represents tangent of theta? Tangent is what over what in terms of the graph, in terms of x, y, and r. It's y over x. What's your y coordinate here? What's your x coordinate here? There you go. Mr. Dueck, shouldn't tangent be negative in this quadrant? Well, the fact that they've told you that x is equal to the coordinate P, that P must have a negative inside of it, because it has to be if you're in this quadrant here. So they didn't give me any negatives to muck around with anyways. Or they can actually give you the numbers and ask you to find any of the 6 trig ratios. So here's x, here's y, you can find r, and then figure out secant is cosine, it goes with cosine, so r over x. Or they'll have you do one algebraically. We've done a few of those as well. So negative a comma b lies in quadrant what, Troy? No, what, Adam? Quadrant what? 2. Where's quadrant 2, Adam? Ah, so we're right here. And a should be negative. I like that. Okay, so x is negative a, y is b. Could I find what r is algebraically? Yeah, r squared is the square root of x squared plus y squared. When you square the negative, it would vanish. So there's r. And they want point N is the point of intersection of the terminal arm and the unit circle centered at 0, 0. Oh, so point N is right there. Determine the x-coordinate of N in terms of A and B. Oh, easy. Had to think about it for a second, but easy. On the unit circle, sine is what over what? But since r is 1 on the unit circle, sine is your y-coordinate, and cosine is your... So if they want me to find the x-coordinate, it's cosine x over r on the unit circle. That was a weird one. I had to think about it for a second. I'll come back if I need to. It says sketch and analyze the graph. You're not going to be asked to sketch a graph, but you'll be able to recognize this stuff. So amplitude, period, 2 pi over b, so 2 pi over 3. Range, domain, asymptotes. How do I find the asymptote of a reciprocal trig function? I cheat. Cosecant goes with which trig function? It's going to have an asymptote because it's reciprocal where sine is 0. Where is sine 0? Oh, except what's in front of the x here? That's a horizontal compression. It's going to have an asymptote at 0 over 2, which is just plain old 0. Pi over 2, pi, oh, there's the pi over 2. Find an equation given a graph. Here's a higher mental process. So if this equation, find the value of b. Okay. b is 2 pi over the period. We're good? Yeah? And we're almost halfway through this document. And that's good because we're almost halfway through the time I have left. I would find the period. I prefer to find nice, easy points, so I would probably use the... Actually, you know what? Even easier, Mr. Dueck, would be to use these two, because then I can start my counting right from 0, can't I? So there's one full wave. It's 1, 2, 3, 4, 5, 6, 7, 8 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 squares. So each square is worth 1/12 of pi. And my period is 8 of those squares. So b is going to be 2 pi Gesundheit over 8 pi by 12. How do I divide by a fraction? Flip it and multiply and simplify, and hopefully it all works out good. Phase shift. Ah! Alarm bell. Not factored. I have to factor out the 4. The phase shift is not that or that. Factor out the 4. When you factor out the 4, the same as dividing, which would give you an extra 4 on the bottom. So instead of a 2, you'll have an 8 there, and it's minus, it's to the right. Pi by 8 to the right. Here's an H, a curveball, domain of the ugly cousin. Now, normally the domain of the ugly cousin, here's what I said to memorize for tangent. I said you needed to memorize that it went through 0, 0. That's how a few minutes ago when I got tan equals 0, I knew that that was one of my answers. I said you need to memorize that it looks like this, with an asymptote here and an asymptote here, where this was 90 degrees. Oh, sorry, pi by 2. Yep. I have no idea what you're saying. Louder? Okay, can I finish this one first? Thank you. So normally the domain is all reals, but x can't be equal to pi by 2, and then every pi after that, because that's the period. Except, Leslie, what's in front of the x here? That's going to be a horizontal compression by a factor of 2. There it is. Had a request for 37? Yes. Say that again, sorry? Isn't what 24 pi over 8 pi? Right here? I don't know. Let's see. It's 10. Did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How the heck did I do that? Tell me sooner if I make a mistake. So it's going to be 2 pi times 10 over 8 pi. Area, is that better? You're going to get 20 over 8, which in lowest terms is 5 over 2. Sorry. Did you notice that right away? And you didn't say anything? Speak up! I know I'm going fast. I have to. I'm going too slow, to be honest. I'm not sure I'm going to make it through the whole course. But try still. Keep going, Mr. Dueck. Keep going. Word problem. Now, they're probably on the multiple choice calculator section going to give you a word problem, but they'll give you the equation. Type it in, graphing calculator. They're either going to give you an x value. By the way, PM would be 6.5. No, it would be 18.5 as your x value. Use the trace button. Or they're going to give you a y value. Let's actually get an equation. Can I help you find something, sir? You good? Okay. You know what? I need to start wearing a lab coat like that, because I have to admit, that is the epitome of nerd coolness to me. Oh. I need to buy a lab coat this summer. Or maybe they make nerd lab coats with like symbols. Oh boy, I should find out. Okay. So this could also be a written question. Now this only shows up on the written 1 out of every 10 exams or so. Almost always there's 2 trig written questions. An identity and a quadratic trig equation. But sometimes. So let's do this. I said if they want me to find the equation, I always want to do a sketch. And I'd like to find highest, lowest, and middle. Middle. See it? Center, 30 centimeters above the ground. So there's the middle. Yep, right there. What's the highest and the lowest? Well, now I'm looking for the radius. Yeah, you know what? When this thing's rolling, I'm going to go 20 centimeters higher and 20 centimeters lower. But I already know my vertical displacement, which is the middle of my graph. My vertical displacement is 30, so those two are wrong. And I know my amplitude is 20, but both of those have an amplitude of 20, so that's kind of boring. Now, it rotates every 15 seconds, which means b would be 2 pi over the period, but Dina, they already have that there. It has a maximum height at t equals 2 seconds. Which trig function starts up high? Positive cos, and what kind of a phase shift is this? To the right or to the left? To the right. That's why the answer is B. 2 seconds to the right. Start there. Okay. Ferris wheel. Well, we just did a word problem. I'll come back to it if I need to. Spring, bad physics, and I think this is the question that they knew. This is the question that I know one of the teachers apparently really likes. The physics in here is terrible. Also because most kids who take physics say, well, it bounces a bit less and 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 a bit less. They think it's an exponential decay question, which it technically is. And so they want to solve it using logarithms and they get 0. So hopefully they'll nuke that question. Transformations. So remember the idea of replacements. Remember, when in doubt, everything's backwards. New graph is translated 4 up. Find an equation for the new graph. So replace y with y minus 4. So I'd have 3 bracket y minus 4. I'd have 2x plus 3y minus 12 equals 5. Oh, they didn't want me to go any further than that. Sometimes they want you to simplify. I could have plus the 12 over, and it would have become a 17, and that also apparently is the same equation. Here, they didn't need me to do that. Nice of them. X minus 2, how does that move your graph? 2 to the right, so a plus 2 is what you'd add 2 to your original point. And plus 3, 3 up. Done a few of those. How is this graph related to that graph? Looks like we replaced the x with a 3x. Horizontal or vertical? Horizontal. Expansion by 3, compression by a third. Which one? Compression by a third, because it's next to the x where it belongs. And everything's backwards. I don't know what's going on with some of the weird glitches here. Higher mental process. So if this is vertically compressed by a factor of 1/5, vertical means that everything's backwards. You're replacing y with 5y. Replacing y with 5y. That's why it's, oh, when you replace a y with 5y and then Leslie, you square the whole thing, that's where the 25 comes from. 25y squared. What is the inverse? First of all, remember it's a reflection about the line y equals x. How do I find an inverse? Switch the x and y around. So here's a basic knowledge question. How do I find the inverse? Switch the x and y around, and they haven't asked you to get the y by itself. Matt, how would I get the y by itself, though? How would I get rid of a cubed? Cube root. I could do that one extra step. They like this question? I put one on your test. This is where you ended up cross multiplying. You ended up with more than one y. How do I turn? Oh, GCF. Here's a higher mental process with some graphics glitches. What page is that one? 66. Let's get it without the glitches. Okay. So for which graph would a horizontal reflection give you the same shape as a vertical reflection? That's what it's asking. So look at these 4 shapes. Which of these, if you flip it this way, also gives you the same graph as if you flip it this way? B, I think. Yeah. Flip it that way or flip it that way. Either way, you get this a peak right there and a valley right there. Okay. Which points are invariant? What's the fancy word for invariant? Okay. So when you flip horizontally, which points are invariant? Anything on the y-axis, anything with x equals 0. When you flip vertically, what's invariant? Anything y equals 0. When you reciprocal, what's invariant? Anywhere 1 high or negative 1 high. So reciprocal graphs, and we're having some trouble with these, so now let's quickly do one of these bad boys. Oh, sorry. They just want an equation for the asymptote. Where will this reciprocal graph, and this is reciprocal, where will this have an asymptote? Wherever the graph is 0 high, x equals -3. Right there. Having a little trouble printing the graphs, are we? 15. This one's tough. If the range of that is that, what's the range of the reciprocal? To do these ones, I always do a sketch. I say, okay, here's a piece of graph paper. Here's a simple graph that has, except let's do a better scale than that, Mr. Dueck. That has a range of -1 to +2. I'll go from there to there. There's an example of a very simple graph that has that particular range originally. Now I'll take the reciprocal of it. I would have a vertical asymptote right there. That's 0 high. Anywhere 1 high or -1 high will be invariant. Little bug, as I walk to the left, my original graph doesn't exist. As I walk to the right, I'm getting closer to 0, shoot off to infinity. So part of your range is going to be everything below and touching -1. Here, walk to the left, closer to 0, shoot off to infinity. Walk to the right, I'm getting higher, so my reciprocal is going to get lower. What's the highest my stupid little sketch here gets? So what's the lowest this is going to get? You know what? Everything above and touching 1/2. Oh, there. Absolute value. Anything that's negative will become positive. The original will stay. So, again, if they give me a range and they want me to answer the new range of a transform function, Leslie, I don't try and do it in my head. I just do a sketch again. So if my original range was from -3 to +5, I'll do a simple graph. How about that? What would the absolute value? Well, let's see. This part would stay as is. This negative part would flip up and stop when I got to +3. You know what? Everything above from 0 to 5, it looks like. Okay? A lot of students want to go from 3 to 5. That's the most common answer kids pick. Here's an H question, a tougher question. Here's my original. What's the absolute value reciprocal? Okay. Absolute value I can do easily. Anything that was below would flip up. So this would be gone. This would be gone. Reciprocal. Is this above 0, Matt? Is this above 0? Is this above 0? Is any part of my graph below 0? Then my reciprocal won't have anything below 0. That's wrong. That's wrong. And now it's a true or false question. Oh, and you know what? Dina, this is my absolute value graph, yes? So is that. That can't be it. I didn't even do the question. I just used the process of elimination. Now, if you want me to actually do the question and prove that this is the right answer, I would say, well, there's going to be a vertical asymptote right there because it touches 0 right there. It touches 0 right there. Anywhere 1 high is going to be invariant. And then we're getting bigger, so getting smaller, getting bigger. And I'm getting that. But if you haven't picked up on the hint yet, start looking at the answers on multiple choice. Really useful. It's basic. Understanding. 24. So here's an H higher order level question, thinking question. Okay. Which equation represents the graph on the right if the original is f of x? Now, I would certainly, Troy, notice I've got a vertical reflection. You know what? They all got vertical reflections. And I would start to notice that there's a vertical expansion, but you know what? They all got 2's there. I'm going to look at the horizontal stuff. Every one of these right now, I would have an alarm bell for, because none of them are factored. Leslie, how wide is my original graph along the base? How many squares? 4. How about my new one? It's undergone a horizontal expansion by 2. That means we replaced x with a half x. No, no. Suddenly got the hiccups. It's crazy. Okay, I've got it down to 2. Let's pick, I'm going to follow this point right here. If I horizontally expanded by 2, instead of 5 right, it would end up 10 right. Yeah, I got the hiccups, told you. Then what? 1, 2, 3, 4, 5, 6 left is one possibility. Do I have a point sitting right there? I'm really focused on that one there. I'm also really battling the hiccups here. Give me 1 second. And I'm battling. So be very careful. Almost always when they give you one like this, Leslie, they will do the alarm bell. Factor, 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 factor. Oh, and when you're factoring a fraction, remember when you're factoring, it's the same as dividing, so it's really 3 divided by a half. That's where the 6 came from. How do I divide by a fraction? Flip it and multiply. I'm sprinting. And I can't remember if I said this right this morning. You have 3 full hours up there. I have not had anyone not have enough time to finish. They used to be 2 hours, and then it was a race. We used to actually teach you when you hit graph on your calculator to move on to the next question while your calculator was graphing, and then come back and do the period. Like we literally were that pressed for time. Then they added an extra half hour, and they added another half hour. So 3 hours, lots of time. When you finish the exam, don't leave. But it's sunny. Don't leave. Stay the full 2.5 minimum. Let your mind wander. Put your head down. Even close your eyes. You'll be amazed at how often an answer will pop into your head. I still had a kid about, good gosh, 6 years ago who had not got a single identity all year. Not one. And on the provincial, this is back when they were mandatory, he followed my advice. He said, Mr. Dueck, I put my head down, let my mind wander, and would you believe, Mr. Dueck, with about 6 minutes left to go, this is what I wrote on my identity. He showed me what he'd written. 5 out of 5. Not a bad way to end your final exam. And the identity is always the last question. By the way, when you finish the non-calculator section, you won't be allowed to pick up your calculators. They're going to be very strict on that. Turn to the end, find the trig identity, do that. Find the transformations, do that. And the provincials are almost always set up so that on the calculator section in your first 10 multiple choice, 6 of them you don't need a calculator for anyways. So don't just twiddle your thumbs. Let's keep going. Here's a nasty. If the point 6, -2 is on that graph, what point must be on that? Leslie's going, what? Don't. First thing, whenever they give me a point, I always write it because I feel better, and I'm gonna cross stuff out and use it anyways. But now it's not blank. I've done something. Let's see. Let's list the transformations now. I see that. That's a horizontal reflection, is it not? I see a plus 4. Is that inside the brackets next to the x? Then that must be a vertical 4 up. And then this whole thing is under a 1. But remember, you're taking the reciprocal of the y value. So let's see. Horizontal reflection. 4 up. Reciprocal. Ah! And when I see my answer there, I smile. So although they called this a higher order question, I'm going to argue actually, if you don't panic, if you carefully look at what order do I do things in, and for this whole thing I use my expansions, compressions, reflections, slides, it's not so bad. So absolute value with a twist. What's the difference between these two here? They both have a 2, they both have an absolute value, they both have a plus 1. Here, this is do the absolute value first, then vertical, so this would be first, then vertical expand by 2, then 1 up. Here, this would be do that first, then do absolute value, then vertical expansion. I'm treating the absolute value like a bracket, and I'm doing what's inside the brackets first. So let's see. Here, absolute value first, so this would end up going to there, to there, to there, to there, to there, to there. So there's the absolute value graph in blue. Now I'll change colors. Vertical expansion, so instead of this point being 3 high, how high will it end up being? 6 high, right there. And instead of this point being 1 high, it'll end up being 2 high. And then what's the last thing? 1 up. Can you see if I move that red graph 1 up, I'm on the black graph. Okay. Here, move it 1 up first, then absolute value, then stretch. Now, this would lose you marks because if you draw anything solid, they'll mark that. So when you're doing your provincial, oh, and this would also lose marks because I haven't done arrows on the end. Okay? Dot there, arrow there. But if you're doing multiple steps, dotted lines along the way, or use different colors, or go over your last one in pen and make a note saying, so if you went over your last one in pen and you said, or pen is final answer or something like that, they're okay with that. But the rule is if you do the whole question in pencil, any solid lines we assume are part of your answer. That's how we're taught to mark them. Combinatorics. Woo! So remember your fundamental counting principle. Remember, combinatorics usually goes in the order that I taught you, which means the first combinatorics question, it'll be pretty obvious, probably is a fundamental counting principle kind of a question. So 45 multiple choice, 4 possible answers. That would be 45 blank lines, which I'm not going to draw. 4, 4, oh, it's 4 to the 45th. They love to do license plate kind of questions or area code questions. It says use factorial notation to determine different ways of arranging n distinct objects, or some of which are identical. So know how to simplify that on your, oh, this is non-calculator. How would I do this without a calculator? I think that's the factorial notation. Can I cancel? Well, this is factored. That's the definition of factorial. So, gone, 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 gone. Right? It's 3 times 5 times 4. 60. Soccer team played 12 games in a season. They won 6, they lost 4, and they tied 2. How many different orders? Orders tells you it's a permutation. could this have occurred? Well, look, they 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Tied 2. That's a word. How many letters in that word grand total? 12. How many W's? 6. 4 losses, 2 ties. That's the answer. Type that in carefully. Write the following without using the factorial symbol. Now, this one here, because it's n factorial squared, that's really the same as n factorial, n factorial. And by doing that, I would mentally break... Oh, don't write over the factorial symbol, Mr. Dueck. I would mentally break this into half. I would simplify this as n minus 2 factorial over n factorial times n plus 1 factorial over n factorial. How did we simplify these? We looked at these, we asked ourselves a question. We asked, which one's bigger? What's bigger, n minus 2 or m? So we start to expand the larger one by subtracting 1 from it. And what's 1 less? That. What's 1 less? That. And I always quit when my term that I'm wanting to cancel appears. Which one's bigger? This is n plus 1 times n. You know what? I'm going to stop there because that already appears on the bottom. These cancel, Rio. These cancel. And I'm left with n plus 1 and an n minus 1. Okay. Number 8. How would I do number 8? This is an H question, so higher mental process. Are you serious? How would I do number 8? Oh, wait a minute. It says non-calculator. Sheesh. It's going to say if it was calculator, I'd be plugging in answers left, right, and center. Otherwise, I guess I'm going to plug this in. This is going to be n factorial all over 3 factorial n minus 3 factorial. That's from the formula sheet. N choose R equals n factorial all over n minus 2 factorial. By the way, what's 3 factorial in your head? I'd probably do this. Now what? I'd cross multiply. I would move this to there and this to there. But for what it's worth, your n factorials are going to cancel. One on each side. In fact, you're going to get that and that. Cross multiply, you're going to get this. N minus 2 factorial all over n minus 3 factorial equals 6 times 1. I left the n minus 3. I just moved the 6 over here. Which one's bigger? So this is going to be n minus 2, n minus 3. Oh, stop there, Mr. Dueck. I have n minus 2 equals 6. What's n? 8. Because n minus 2 equals 6. That's where the 8 came from. Looks scary? Don't panic. Okay? Solving a factorial equation for n with the quadratic ones, so this occasionally appears on the written section. Recognize, first of all, that 3 factorial is 6. Simplify your factorials. Which one's bigger? Cross out, and cross multiply. It's a lovely quadratic. And don't forget, you're going to almost always get an extraneous because you can't do a factorial of a negative. Now, your calculators, some of your calculators, may let you do a factorial of a negative. You can't. There's something called a gamma function, which lets you deal with negative numbers. I think it's called a gamma function. And it seems that the TIs may take that into account, but no. So, here's an H. 2 English books, 3 chemistry books, and 4 math books. If the English books, the chemistry books, and the math books are all identical, oh, you know what? That sounds like a word. How many different ways can they be And remember, arranged means a permutation. What is that? 5, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 factorial over 2 factorial, 3 factorial, 4 factorial. If they're all different, in how many different ways can they be arranged on the shelf? Now, if they're all different, then they're not a word. They're all different letters. 11 factorial. 11 blanks. It's 11 times 10 times 9 times 8 times 11 factorial. If the English books, the math book, chem books, and the math books are different, how many ways can they be arranged if the chem books have to be grouped together? So now we'll go to our little Scrabble tile analogy. We have chem 1, chem 2, chem 3, and then 6 others. You can mix up those others 6 factorial ways. How many ways can you mix up these 3 guys? 3 factorial. Hope that's it. Let me see. Why 7 factorial? Oh, there's 7 different letters in this. 6 and 1 big letter. Sorry. 7 different Scrabble tiles. 6 individual ones plus that. 7 of them. Should have caught that. Why is B... Did I say 11? Sorry, ask me again. Oh, I got 11 on the brain for some reason. Thank you, Troy. You know why? Because the previous question that had repetitions had 11 things, I think. I'm going to clear my brain out. Okay. How many ways if all the same subject books must be grouped together? So you have a chemistry Scrabble tile, a math Scrabble tile, and an English Scrabble tile. How many Scrabble tiles do you have grand total? 3. However, how many chem books are there? 3 of them, so you can mix them up that many ways. How many English books are there? 2 of them, so you can mix them up that many ways. How many math books are there? 4 of them, so you can mix them up that many ways. Just did one like that. By the way, for what it's worth, combination locks should be called permutation locks because order matters. Combination lock, actually it's a permutation. They named them wrong. No. Order matters for permutations. So a combination has 60 numbers on the dial. It works by turning it first to the right, then to the left, then to the right, with 3 different selected numbers needed to open the lock. Selecting these 3 numbers. Does order matter here? That's a permutation. So the classic written questions, committee questions, 5 boys and 6 girls on a grad committee. I'll be honest, this hasn't showed up on the written recently because they emphasized other units more. But so if order doesn't matter, bucket. So 2 boys and 2 girls. Boys, girls, 5, 6. We want 2 and 2. 5 choose 2, 6 choose 2. 5 choose 2, 6 choose 2, 150 ways. What if there must be at least 1 girl? So at least 1 girl means 1 or 2 or 3 or 4. Bucket, 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 bucket. Or you could have used a complement. You could say how many don't have any girls on the total number minus. Usually I only use complement for probability. Remember your binomial expansion theorem? Okay, how many terms are there going to be in the expansion when there's a to the 10th there? Don't say 10. It's 11, right? How do you know? Because if I give you this and you FOIL it out with a 2, how many terms will you get? 3. That's 1 more. Or even if I give you this, exponents of 1, but how many terms are there going to be when you FOIL this one out? Which seems silly, but 2. Can I make it? You sure? Okay. You need to stand up. You need to stretch. All right. Pathway problems. Can I multiply down this pathway? Yep. Probably one. Sorry? Are you asking about trying to find a specific term? Patience. It's going to come up later, I guarantee you. We haven't, because that's an actual formula. So we haven't actually mentioned that formula yet, so they're going to have a couple of questions on that formula. Oh, Pascal's for this one, yes? 1, 1, 1, 1, 1, 1. Nothing really there. I guess new 1. New 1. Oh, what goes here? What goes here? What goes here? What? Oh, I already did that. What goes here? Nyeh. Here. Nyeh. Here. See it? 5. Nyeh. Oh, I should do this one first. What goes here? 9. 13. New. 9. New. 22. Right? Question? Because it's that and that. No, it's not. It has nothing to do with the box. It's what flows into that junction. What flows into that junction? A 3 and a 4. That's how this works. It's nothing to do with the shape. It's what flows into your specific junction. Heck, I could build these with curves if I really wanted to. Be awkward, which is why we don't, but I could. Question, Bo? Okay. Okay, the 10th term in this is x to the 5th. First thing I check and I notice, you know what? There are no other x's, just a single solitary x with no exponents. So if my 10th term was x to the 5th, that means my 9th term was x to the 6th. 8th term was x to the... I'm losing you. Look up. Let's suppose there was a 7 there. I'm just making this up. This would be x to the 7th. 7th, Mr. Dueck. I'm losing me, apparently. X to the 7th, x to the 6th, x to the 5th, x to the 4th, etc. And there'd also be chooses, but I don't care about those right now. I'm just trying to find right now the exponent. So if I back count, my first term is that. My second term is that. If my 10th term is an x to the 5th, which one of these is correct? What did I start out with? You might think 10 plus 5 is 15, so I would try that first. I would go, well, 15, 14, 13, 11, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5. Oh, my 5 appears on my 11th term with a 15. So I would say, maybe it's the 14th power. And it is. It's the 14th power. Here's your question. Determine the 8th term. This is where we use this thing. Is this what you're asking me about? So if I want term 8, what does k have to be? Yes. What's n? No. Yeah, don't do that. Easy. N's the exponent, 11. A is 2x. B is negative y. So you're going to get 11 choose 7. 2x to the 4th. Negative y to the 7th. Okay. Please notice you will get a 2 to the 4th as part of your simplification. Don't forget that. And you will get a negative to the 7th. Your final answer is going to be negative. Those are wrong. Higher mental processes. Which of these is a constant? So what I said here was write out the first 3 spotting, looking for a pattern. So what's my exponent here? So it's going to be a to the 10th, a to the 9th b, a to the 8th b squared. Here I'm going to have a 1 over 2x squared to the 10th. I don't care about the 2, I just care about the exponent. I'm going to have a 1 over x to the 20th. Here I'm going to have a 1 over 2x squared to the 9th, negative x cubed to the 1. Again, I don't care about the 2 or the negative. How many x's do I have on the bottom? 18. How many do I have on the top? 3. I'm going to have 15 left on the bottom, and I say, hey, maybe I'm going up by 5s. What are we pointing at? Oh, chips. Gotcha. Okay. If I did that over here, I would find them going up by 5s. I would say this. First term, 1 over 20, 1 over 15, 1 over 10, 1 over 5, x to the 5th, 1 over x to the none. You know when there's no x's? 5th term. Fingers, fingers, fingers. Probability. Woohoo! Is that the last unit? I think so. Okay. So, remember your binomial PDF. How do you know when to do a binomial? First of all, the number of trials is more than 2. 2 tree. More than 2, it's either a bucket or a binomial. How do I know which is which? A binomial probability distribution function, Dina, means the odds never, ever, 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 ever change. Which means it's not a bucket. Bucket was a card question because a card question, the odds changed each time you picked a card. They changed each time you picked a card. Hang on here. Hang on. So that's how I know it's a binomial. This one here wants at least 4 out of 5 mornings. What does at least 4 out of 5 mean? 4 or 5. So you can go binomial PDF 5, 0.9, there's 4 days, 4 times. There's 5 times, add them together. Or you can use the longer version on your formula sheet, which was this one here. Use a shorter one. Okay. So the above experiment is a binomial experiment with 5 independent trials where the 2 outcomes are either success or failure. A little technical, by the way. It says if you're going to use this on the written, make sure you show the keystrokes. Show what you typed in. And you know how to do it on your calculator, yes? So multiple choice test has 12 questions. Each question has 4 choices. Will the odds ever change, or it is always 1 out of 4? This is binomial. What do they get? None of the questions. That's considered a basic understanding. Here's a higher order. At least 7. At least 7 means 7 or 8 or 9 or 10 or 11 or 12. And you could do each of those. The easier way to do at least 7 would be 1 minus 6 or less. 1 minus binomial CDF of 6 or less. Because if you lose 6 or less, whatever's left must be 7 or more. Okay? H questions, Mr. Dueck. Let's see what this one looks like. One of 2 cards is black on one side and white on the other side. The second card is black on both sides. One card is selected at random and the side facing up is black. What's the probability that the other side of the card is white? Well, there's 2 cards. I'm pretty sure I'm going to use a tree approach. I just got to think about my tree. I think I would say this. You can pick card A or card B, and I think there's a 50-50 chance of picking up either card. In card A, it can be black or white, black or white. Now card A is the first card, which is black on one side and white on the other. So it's got a 50-50 chance of that. The other card is black on both sides. You get a 1 out of 1. Come on. 0. So one card is selected at random, and the side facing up is black. What's the probability that the other side is white? I'm blanking on this. I think I'm going to do a different tree. I think I would do this. So when you pick your first card, it can be black or it can be white. Okay? How many sides are there grand total here? 4. How many sides are black? Is that okay? I mean, I'm seeing a 1 out of 3 popping out of here. Let me come back to this one. I'm having a brain cramp. Let's keep going on. Something stupid, obvious that I'm just not seeing. Dependent. Remember, dependent means the odds of the first one occurring affect the odds of the second one occurring. So, which of these are dependent? Anytime you're picking cards without replacement, it's dependent. Because what are the odds of getting... Oh, here's my deck of cards still here. So I pick a card. What are the odds that this is an ace? It depends. You know what it depends on? Whether that card was an ace or not. Because if that card was an ace, how many aces are left in the deck now? 3. If that card wasn't an ace, how many aces are left in the deck now? 4. It depends. Dependent. And the answer to that question in real life was 0. Okay? Coins are not dependent. Coins and dice are independent. The previous roll has no effect on the next roll. I could roll 5 6s in a row. You know what the odds of getting a 6 on the next roll? It's still 1 out of 6. Okay? If they give you a dice question, do a little sample space. Often they'll give you the sample space. Mutually exclusive. What does mutually exclusive mean? Mutually exclusive means can't happen at the same time. So look at those events there. Which of those can't happen at the same time? Sorry? Can you add to 5 and have the first dice be a 1 at the same time? Yeah, I see an example of that there. Can you... I'm kind of right now... Well, can you have the first die be a 1 and the second one be a 4? Yeah, right there. Can the second die be a 4 and the product be a 6? Let's see. Product. What does product mean? Multiply. So if the second die is a 4, that's this row here, can any of those multiply to 6? You know what? And I didn't need to even look. I went, wait a minute. 4 doesn't go into 6 evenly. It can't possibly multiply to 6. So the answer here is C and D. Can't happen at the same time. There's your Venn diagram approach. Okay. Deck of cards. Oh, it's a nice card graphic. I may actually copy that. I didn't even know that was there. Things I learned. What does OR mean? And technically it's add minus the overlap. Now here with the chart, if they want to find the probability of a heart or a face card, I'll be honest, I would just go, there's my hearts, there's my face cards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Because remember I said if we can count it, we can solve it. But you could have gone hearts or face cards minus the overlap. How many hearts are face cards? So there's the equation. Oh. Diagram is provided as an instructional tool and may not be provided on an exam. So you might actually have to know what the cards are. 2 dart players each throw independently 1 dart at a target. Probability of each player hitting the bullseye is 0.3 and 0.4 respectively, which means in that order. What's probably at least one of them hit the bullseye? Okay. Bullseye for the first guy. Not bullseye for the first guy. Or how about hit, not hit? And the second guy, hit, not hit. So 0.3 chance of hitting, 0.7 chance of missing, 0.4 chance of hitting, 0.6 chance of missing. At least one of them is this one or that one. Now they used or. I probably would, oh there it is, right there, 0.58. You could also have said it's one plus the other minus and what does and mean? Multiply. I guess you can get there with the equation as well. I like the tree. So much more visual. And they're fun to draw. It's trees. Okay. Or you could have somehow used a Venn diagram. I would never use a Venn diagram here, but fair enough. Okay. So, here's an H question. Bag A contains 1 black and 2 white marbles. Bag B contains 1 white and 2 black. A marble is randomly chosen from bag A and placed in bag B. And then we're going to choose a marble from bag B. What's the probability that's white? Sounds ugly. It's actually not bad. So first thing we're going to do is we're going to pick from bag A. So I'm going to make a little note right here, bag A. And in bag A, we can have black or white. What are the odds of getting a black marble in bag A? 1 out of 3, 2 out of 3. Now, once I've picked, then I'm going to pick a black or a white marble from bag B. Now, down this branch, we picked a black marble from bag A. What did we do with that black marble? Put it in bag B. So how many black marbles are there actually in bag B down this branch? 3 out of how many, Dina? 4. 1 out of 4. Down this branch, we picked a white marble. What did we do with that white marble? Put it in bag B. So how many white marbles are in bag B now? 2 out of 4 and 2 out of 4. There's our tree. And if you get that, the rest of this is easy. What do they want you to find? 1 out of 3 times 1 out of 4, or plus 2 out of 3 times 2 out of 4. Okay, so if they give you that mix and match bag question, no problem. Just have the first event be whatever you picked from the first bag. The second event be whatever you picked from the second bag. You don't include picking bag A or bag B because they told us the order. They told us that happened. Okay, the factory defective conditional probability. They're doing a sideways tree. I do my trees vertical. So machine A produces 60% of a product. Machine B produces 40%. 3% are defective. So A or B, 60%, 40%. Defective, not defective. Not defective would be 0.97. Not defective would be 0.98. If that's given that you're defective, what's the probability that it came from bag or factory B? Defective is the final level. We're moving up the tree. That's why this is conditional probability. and this is going to be the probability of B and D, the branch that has both of those, divided by the given one, any branch that ends in that. The branch that has both of those is that branch. It's going to be 0.4 times 0.02. Any branch that ends in a D is that one or that one. What does or mean? Add. So that branch, 0.4, 0.02, divided by that branch or that branch. Okay. Here's another one. 3 boys. This probably, even though it's 3, I'd still use a tree here. So 53% of graduating students are boys. 3 grads are chosen at random. Now, this question is a bad question. We had a big, long discussion about this because somebody said, Mr. Dueck, as soon as you picked one grad, one boy, wouldn't that change the odds of the next person being a boy? Because it's just like a deck of cards. You got maybe 100 boys in your grad class. It's like 100 deck of cards. Yes, but they're saying the odds never change, so let's presume we have an infinite grad class. It's stupid, but okay. So boy, girl, there's your tree. What do they want you to find? Given, wow, that pen didn't lift. Given at least 2, find that there are 3 boys. Okay? Which is going to be and divided by the given one. Now this is tricky. Well, at least 3 boys, sorry, at least 2 boys, that's this branch, or this branch, or this branch, or this branch. I don't think any other branch has at least 2 boys. Okay? So the bottom is going to be 0.53 cubed. That's their shortcut instead of writing 0.53, 0.53, 0.53. And then they notice that 2 of the branches, actually all 3 of the branches are identical. The other 3 branches are 2.53s and a 0.57, 0.53, 2.53s and a 0.47, 2.53s and a 0.47. So that's where the 3 came from. Of these 4 that are highlighted, because those are at least 2, how many of them are also 3 boys? What's the overlap? What's the and? Only that branch there. And that's the tricky part when you're saying 3 boys and at least 2 boys. Actually, that just means 3 boys. Okay? Think about it, right? If you have at least 2 boys, and I'm telling you out of those groups of at least 2 boys, which ones also have 3 boys, really that just means exactly 3 boys. It's weird grammar, I know. You can technically, according to them, do this with binomial. I would do it with a tree because I would not think of this as a binomial because I think it's a dependent. Anyways, we had a big discussion and argument. A student in Oak Bay Secondary emailed her teacher, and she said they want an accurate answer to 4 decimal places. She actually worked out how many students you would need to have in your grad class to do this with a proper tree going down by 1 and not have the odds change for 4 decimal places. And it was like a grad class of 10,000 or something like that. She said this is stupid, and I agree, it is. But there it is. So Venn diagram questions. Okay, find the probability that A occurs given that B has occurred. 2 out of 7. So given that B has occurred, you know you're in that circle there. What's the probability that A also occurred? 2 out of those 7. Okay. The disease question. I haven't seen a provincial for a couple of years, but Elizabeth, I gotta be honest, right now I'm betting on the disease question. That's where I think it's going to be. So what's the disease question? You have the disease or you don't. You test positive or negative, And remember that you test positive when you have the disease 98% of the time. You'll test negative when you don't have the disease 98% of the time. And then this is where you found, in this particular example, even though you've tested positive, you only have a 37% chance of having the disease. Okay. Trees. I'm just really quickly blazing through here. Don't forget some permutation questions. And boys and girls, I think that is a rough summary of the entire course. Take a 2-minute break and then I'll do Q&A about specifics. Specifics, anything from any of the 4 exams that I gave you or any type of question, I'll try and find one like it. What would you like me to go over? Now is your chance to ask. Log asymptotes are inside the brackets. Right? Okay. Come on. Do this, Mr. Dueck. Okay. 2 types of equations for asymptotes. We have this, y equals 2 to the x minus 3 plus 1. And we have this, y equals log base, 2 of x plus 5 minus 7. So here's your answer, Alyssa. This is based on an exponential equation. This is based on a log equation, which is the inverse of an exponential. You remember I did that stupid thing in class? Every exponential graph looks like this, or that someone got hit in the head. So every exponential equation looks like this. What's its domain? All reals. Domain, all reals. What's its range? Okay, here, everything greater than 0. So for this question here, what would the range be? It's been moved 1 up. What's the asymptote? Well, the asymptote here is y equals 0, the x-axis. Been moved 1 up. Okay, now let's walk over here to the log equation. What does a log equation look like? Well, it's an inverse of this. As a matter of fact, what it looks like, you sit and think about it for a while, is that. Okay, so what's its domain? Well, first of all, what's its range? All reals. What's its domain? Its domain is everything to the right of 0, except for some reason my pen is, the district's crappy antivirus program is running a virus scan even though I told it not to, and you can see how it's been slowing down my machine the last half hour and how everything's been smearing. I've tried to tell them that. Now I've got it on video and I'm going to email them and say I'm going to uninstall this piece of garbage. I can't teach with it. Okay, what's the asymptote? Well, here it's get closer and closer to the y-axis. The equation of the asymptote is that. So what would the equation, well, first of all, what would the domain be of this graph here? Domain is x, Mr. Dueck. We've been moved 5 to the, so everything to the right of -5. What would the equation of the asymptote be? X equals -5. Now that's if they're asking you all sorts of stuff. The quick, simple way to get the domain is you say, what can't I take the log of? I can't take the log of a negative. What's inside the log? What's inside the log has to be greater than 0. What would happen when I got the x by itself? Can you see? I end up right here. Okay, so you really got 2 ways to go there, and it's always nice to have several ways because it helps it all crystallize. Good question. Next. I can in a couple seconds. Which one? Which exam? Sorry. Form A? What number? 23? Yep, good. Word problem. Clip. We carefully typed this in. They gave me the equation. Yay! I make sure I'm in radians. Are you in radians? Okay, because you're physics as well, so I have to be careful of that. Clear, clear. Okay, I'm abandoning the scan. There, now it goes fast again. Negative 20 cosine of 2 pi x over 40, close bracket, plus 23. Okay. View window, x is time. How long to go around once? Oh, you know what the period is? 40 seconds. Can you see it there? So I'm going to go from 0 to 40. Scale, oh, I got 4. That sounds good. Height, I'm going to go from 0 to... Excuse me, what's my range? What's the vertical displacement? What's the amplitude? Never negative. 20. So what's the highest I'm going to get is 43. I'll go to 50. Okay? And then they want to find the time when we're 15 meters above the ground, which means I'm going to send a y2 of 15. Yes? It's a y value. Graph. I'm getting a lovely, lovely, lovely wave. Ferris wheel goes up. Ferris wheel goes down. And do they want the earliest time? Second function, calculate, intersection, first curve, second curve. Close enough. Is that okay? 7.38? What were you doing? Okay, so be careful with brackets and stuff. Any others? Can I do an identity? Sure. You want to find one? Or, heck, I'll find one from here, maybe. Oh, no, not from here. From here, maybe. Oh. I passed no trig? I did. And let's do a nasty one. There was a higher order trig identity that I just glossed over. As I said, I'd come back to it. I remember seeing it. Let's see if I can spot it. Here it is. Apparently this is a nasty. So we'll try it. Clip. Okay. This was an H, so this is supposed to be a tough one. Oh, I'm not going to do that one right away. It's got secant reciprocal and cosecant reciprocal. Let me find you a better one to start out with. We'll come back to that baby, though, because that's calling my name, and I'd love to try that. Here's a H identity as well. So, click, clip. Let's prove this puppy. Okay. Remember, if I do any substitutions, brackets, 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 if necessary. Sorry? You have to have the X's in first line and last line. But really, just get in the habit of putting them there all the time. Well, sine 2x, that's an identity from my sheet. And you'll get a half mark for doing that. So I'm going to go 2 sine x cos x. I'm starting with the uglier side also because I noticed this is already in terms of sine and cos, and there's no squares kicking around. What can I do with the top? What are you folks seeing on the top there? I would factor a GCF out of 2 cos. I would factor out. Common factor. See it? Yeah? So I'm going to go 2 cos, 1 plus, because I get a 1 when I factor it, and factor out a 2, factor a 1 plus cos left behind. Can I cancel? Is it factored? Then I can cancel out the 2 and I can cancel out the cos. And I end up with 1 plus cos x all over sine x. Now what? I can't rewrite anything. It's all in terms of sine and cos. Do the right side. What can I do on the right side? We have a fancy schmancy name. I'm looking for one little word. Elizabeth. Okay, here's where I'm going to use the conjugate because I already factored. I've looked for other known identities. Done. As a last resort, especially when I have a binomial two-term denominator with no squares, conjugate. Now what's the conjugate? Top and bottom by 1 plus cos. 1 plus cos. By the way, what did I multiply on the top? What do I have on the top over here? Woohoo! You're probably on the right track. Now when I do that, on the top, I'm just going to leave it factored for one more line because I've learned, Dina, with conjugate that often I want to factor everything when I'm done anyhow. So I'll leave that factored. On the bottom, I am going to have to do some FOIL. It's going to be 1, and then it's going to be minus cos plus cos. See it? You know what minus cos plus cos is? Minus cos plus cos? 0. And then I'm going to have a minus cos squared. Now, why is that nice? You know what 1 minus cos squared is? I have no idea what you said. With authority, like you're right. Yep. Can I cancel? It is factored. And I'm done. I have a 1 plus cos left behind and a sine x left behind. All right? Ow! Here we go. This is about as tough as they'd ever throw at you. In fact, I'll be honest, I don't think this would ever make it on the written. Maybe as a, I don't know. But this looks to me at first glance like it's got everything. I think we're going to be working on both sides. This bugs me. Although cosecant is 1 over what? What's 1 over cosecant then? Think about it. Yeah, if cosecant is 1 over sine, 1 over cosecant is just plain old sine back to the way it was. In other words, you know what this really is? Secant is how do I divide by a fraction? Flip it and multiply. This is going to end up being sine 2x minus tan x cos 2x. I like this because I only got one choice for sine 2x. Sine 2x is always 2 sine x cos x. By the way, on the most recent mock exam, I noticed a lot of kids doing this and saying that was 2 sine x cos x. No, the x has got to be inside, folks. It's not a 2 anywhere. It's a sine of 2x. This is not the same. Minus, well, I got a sine and a cos. Tangent is sine x over cos x. Cos 2x, I got 3 options on my formula sheet. Which one do I want to use? I'll be honest. If I had over here a minus 1, I'd use the one that had a minus 1 here because a minus minus would give me a plus 1. If I had over here a plus 1, I'd use the one that had a plus 1 over here because a minus plus would give me a minus. Do I have a minus 1 or a plus 1 over here? Then I'm going to use the cos squared minus sine squared one, which we hardly ever use, even though it's the first one. Also because, do I have sines and coses over here? Then why don't I bring in one that's got sines and coses? It may not be the best, but at least that makes an intelligent guess to me. Oh, and now what? Adam, I think I'll try writing this as one big ugly fraction because this is one big ugly fraction. Gotta try something. And it's a fairly nice common denominator because this is technically over 1. Adam, what's my common denominator? So if I hear you correctly, I would multiply the top and the bottom by cos x. And that's going to give me 2 sine x cos squared minus, because this is already over cos, sine x cos squared plus sine cubed all over cos x. Now the cubed makes me a little bit nervous here, but you know, they said this was a nasty one, so bring it. I say bring it. Oh, I have 2 sine x cos squared minus 1 sine x cos squared. Those are like terms. At least now I got a bit of, not my nerdy adrenaline rush yet, but I started to smile because that can't be a coincidence that I get these hideous looking, oh, like terms. So I'm going to rewrite this as sine x cos squared plus sine cubed all over cos x. How's that help? Factor out a sine? Okay, don't quite know where we're going. Sine x, and I'll have left cos squared plus, oh, look at that. Why is that so nice, Sally? What equals 1? You mean this whole thing is sine over cos? It's tangent? Now I know I must be on the right track. That can't be a fluke. And I've been very careful not to make any algebra mistakes. Even Dylan's smiling. He's got his early adrenaline rush on. I agree. And I think I'm done the right side. That's so much fun. Let's go back and tackle the left side. Well, I got 3 trig functions. Let's rewrite everything in terms of sine and cos. This is sine over cos plus, if I have one fraction, I want everything to be fractions. Elizabeth, is this a 4-level fraction? Have I taught you a wonderful, handy-dandy, really, really worth learning skill, trick, whatever you want to call it? If you have a 4-level fraction, find all your mini fractions, common denominators. In this case, it's cos. What we're going to do is we're going to multiply the top by cos and the bottom by cos, because that's allowed. What is cos over cos? So I'm not changing anything, except, Dina, I always said, since you have 4 levels, keep 4 levels. And when I do this, what cancels on the first term? Cos, and I get just plain old sine x plus, nothing cancels here. I'll get sine x cos x all over. Does anything cancel here at all in the bottom? Then, Leslie, I've always found when you're multiplying, if nothing cancels, it's worth leaving it factored for one line. So I'm going to leave this as 1 plus cos times cos x and just forget all the ones. In fact, I don't really need a bracket right there. I can just write it like that. Matt, now what? Wait, oh, the top GCF? Okay. Oh. Can I cancel? Is it factored? Now, I'm going to pause the recording. So, not what I wanted to hit. Apparently, that's not what I wanted to hit. Try that again. Pause the recording. I've had a request from one of my top students, and he's lucky he's one of my top students, to try that black card one, white card one that I botched earlier. So, let's go try it. Where was it? I don't think it was quite this far back. Oh, it was. Well, it's an H question, which means it's supposed to be tough. Mm-hmm. That's what I think I would handle this. I would say every side has an equal likelihood of coming up because there's 2 cards, which is 50-50, and the 2 sides are 50-50. So you have 3 black sides and 1 white side. And if you know one side is black, I think 1 out of 3. I might try it that way. Sure. Of getting white. I was trying to get there still. I'd still like to be able to get there with a tree. But I can't. The other reason, by the way, is I've never seen this question show up. So I'm guessing it's been tweaked and worded differently or clearer. Pardon me? Well, first of all, I would probably go card A and card B, and then for colors choose white and red, because one of the things we've tried very hard to do is if we have bucket A and bucket B, we don't want to give you a color blue or black, because then you have in your tree B and B, and at least once this year I know I marked a paper where it was clear a person got the B's mixed up with each other. So I always try, I like red and white or red, white, and yellow, and then bucket A and B, and that way there's no letter overlap. Okay. Any others? Yeah. From January 2008. Sorry, which one? Number 8 on the non-calc?
Just a reminder to staff with the grad meeting happening now in this room. That's the grad meeting.
Is that this one here?
In this room now.
Okay. Absolutely, this is a good one to do. Flip. Okay. Quadratic trig. Probably 4 answers. I'm already in my mind crossing out A and C, but I'm not going to until I get one step further. Here, there's a big difference between this kind of quadratic trig and this kind of quadratic trig where you have a cosine and a cos squared. Here, the only approach is make it equal to 0 and factor it. When you only have a squared term, the shortcut is get the squared by itself. Divide by 4. I'll get cos squared x equals 3 over 4. How to get rid of a squared? Square root, remembering what? Plus or minus. So when I square root both sides, I'll get cosine equals plus or minus. You know what the square root of 3 is? You know what the square root of 4 is? Now, because cosine is positive or negative, they're positive there, they're negative there. Now I would definitely cross those two out. There's going to be 4 answers. Do I have a triangle? By the way, I'm guessing this is the step that you were stumped on. Oh, okay. Do I have a triangle with a root 3 and a 2 in it? Elizabeth, I'm going to draw my 1, 2, root 3 triangle. Only if you put the angles in the right place. Apparently you didn't on the final when it counted, girl. Sorry to throw that out there, but yeah, I have no, like if you draw it this way, which is fine, but make sure then that's pi by 3 and that's pi by 6. Okay? Remember, the textbook actually called those 2 separate triangles, and I said, that's stupid. They're the same triangle. Let's just memorize 1. Because they always had 3 triangles, but they only put the 30 in one, and they only put the 60 degrees in the other. And well, look, if this is 30 degrees, this is 60 degrees. It's the same triangle. So we're trying to cut down on our memorization. If I keep going, by the way, Adam, which of these 2 angles, top or bottom, has a cosine of root 3 over 2? Yes? What's my reference angle? Pi by 6, and right now I'm quitting. It ain't that, it's that. But you could go, right, pi by 6, pi by 6, pi by 6. That's 6 pi by 6, that's 12 pi by 6, and find all 4 angles. That would also be fair game as a written question asking you to find all 4 angles. Although if they gave you an easy quadratic where you didn't have to factor, they'd probably have a part B, give the general solution, or something like that. Is that okay? I'll go about 10 more minutes, and then I'm going to kick you out for lunch and wander, and then I'll meet you back upstairs. Any more? Just curious, how many of you have done all 4 of the provincials that I gave you? There's a stem to stern all 4, not 3, all 4. There is a very good chance you won't see a single new question. Okay? In other words, there's a very good chance, you know what? Let's maybe say 2 multiple choice questions, but otherwise the odds are fairly good you've seen every one. So the message is, again, relax. And if you come to a weird one, just think, actually I probably saw this, I just can't remember because I'm in my test stress mode. Relax, circle it, come back to it later. The only part you have to somewhat rush on is the 16 non-calc questions. Make sure you get those done. But I would say spend the full, I think you're allowed 35 minutes or 45 minutes. Spend the full 45. You have 3 hours, lots of time. So spend the full 45 on those non-calc, wrestle with it, think, and then get in the habit on part 2 of, if you don't know how to do something, circle it, come back to it. But make sure you do come back to it. You'll also find in the exam, so in the very, I think it's in the middle, there's a formula sheet that's perforated. There's a couple of blank scrap pieces of paper that you can pull out that are perforated, and a couple of blank pieces of graph paper that you can pull out that are perforated. So you got lots of room to try stuff. Do not erase things. That's a waste of time. If you think you're wrong, leave it. Every question has 2 pages. Go to the second page, and if this one is right, put a big X through this one, but never erase. Always cross out. Erasing is a waste of time. Neatness, don't worry about it. I'll give you another one. Have I gone on about the answer blanks? On the written, Okay? On the written. Oh, maybe they've stopped putting answer blanks on there. Let me check another one. There's the middle section. You saw rough work for multiple choice. Oh, looks like they've... If they have an answer box, don't put your answer in there. Okay? What you're supposed to. And whoever's upstairs might even say to... Don't! I marked exams for 5 summers. The number of times I saw the right answer here and then kids copy it down wrong into the answer box would astound you. That's throwing away marks. And as soon as you write it there, that's the one we have to mark. So one of the first things I learned when I was marking provincial exams my first year, I had all these experienced teachers. What, you tell your kids to put their answers in the box? What, are you dumb? That's just throwing away marks. And even if they say you must put your answer in the answer box, don't. They'll find it and they'll mark it. Okay? They will mark always, though, the last thing you write. So if you narrow it down to 2 answers and you want them to mark this one, you must cross out this one. Okay? I would box it, write the word answer, and draw an arrow pointing towards, like, we are taught to mark almost like robots. And one of the things that we are taught when we're marking them is whatever they wrote last, that's what they've committed to. Okay? Unless it's very, very, very clear. So you know what I would say? The effort it takes to box it with an answer underneath is far more work than just crossing out the answer underneath, isn't it? Do both, but whatever you write at the end, that's what you're committed to. Make sure you round off properly. Okay? If you round a 0.6 downwards, they'll take a half off for a Math 8 mistake. You don't want to do that. Make sure you have your, and Rio, I mentioned this earlier, make sure you have your cell phones powered off, and I wouldn't even have them in your pocket. My worry is partway through the exam, to check the time, you'll do this, and if you look at an electric device, we have to give you a 0. So don't do that. Okay? Other advice, dress cool. You're going to be in the library where it's air conditioned. You want to be a bit chilly. I would not be wearing a jacket up there. Okay? Now is fine, but you want your heart rate to be elevated. You want your blood flowing to try and keep your body cold, warm. It gets more blood to your brain. Last thing you want to be doing is wrapping yourself up in layer after layer after layer after layer. If you can, bring a beverage. I would say a caffeinated one, but I would not drink an energy drink right now because you'll crash about 2 hours in. You probably could bring an energy drink with you, and yes, studies have shown that caffeine does help your memory and help you recollect things. Don't go overboard on that. Your young bodies can't handle it. My old body can't handle it. Other hints that I would give you, trying to go off the top of my head here. Remember on the calc section on the written, you can often check your answer using your graphing calculator. For example, I said that this was a classic written question right here, solving an exponential equation. You understand you have to solve it algebraically, which is why they include that. When you're done, clear, 2 to the x, left side. Right side, 3 times 5 to the power of bracket x plus 1, right side. Zoom, standard when in doubt. There's the left side. There's the right side. Well, sorry, taking a while. There's the right side. Second function trace, intersection, enter, enter, enter. Find where they cross, and you will find negative 2.9544 is your answer. You can always check your answer that way. You can also, if it's a logarithmic equation, like this boy, you can check it this way. How do I type, clear, how do I type type log base 4? Log x over log 4. Just the same way you would type it when you're trying to evaluate it. Minus How do I type log base 4? Log x plus 3 over log 4. Close bracket. There's the left side, right side 1, graph. Second function, intersection. First curve, second curve, guess. Oh, I have to move over a little bit because I was sitting on an asymptote, so it was saying that I couldn't guess there. X equals 6. Was that the correct answer? Hey, and it even got the rejection for me. Okay, so on a lot of these, you can check your answers on the calculator section especially. If you're on the calculator section and it's a wonky identity, well, even here, so let's suppose they gave you this on the written section. Oh, it says exact values, but I can certainly go clear, sine of 1/3 times x, enter, root 3 over 2, enter. Here I'd go zoom trig. Oh, they want from 0 to 2 pi. There was no domain here, so I'll change this just a little bit here. Window from 0 to 2 pi. Oh, it already is. Graph. You're fine. Don't worry about it. I'll go up there and ID you. I'll go up there and ID you. I know. They didn't announce that, and so it's not your fault. Second function. Intersection. First curve, second curve, guess. Now this gives you an answer as a decimal. What is that decimal right there? 3.1415927. I think that's pi. Second function, calculate, intersection, first curve, second curve. Let's see if there's another one over here. Enter. Now 2 pi technically isn't in the domain, so it didn't find it. Even if this was a decimal you didn't recognize, if you know it's an exact value, write it down to 6 decimal places, divide it by pi on your calculator, and often you'll recognize the number that's left. For example, if you saw 4.712388, 89, you went, okay, 4.712389. You copied that down, and then on your calculator, you went 4.712389 divided by pi. I hope you'd clue in that that's 1.5, that's 3 over 2, that's 3 pi by 2. You can bail yourself out on a lot of these, or confirm a lot of these. That's why they went to a non-calculator section, because it was too easy to be clever and, well, cheat, sort of. Okay? Here endeth the lesson. Folks, you want to be upstairs by 12:45 in half an hour.